It sits in the furnace, a luminous coil of stars wound like a mainspring, NGC 1425, the cosmic spring, a spiral galaxy about 70 million light-years away whose arms curl in a poised, athletic sweep around a calm, bright core. Look closely and you can see what the Hubble sequence calls an SARS-B design: no central bar, moderately tight arms, and a subtle inner resonance ring where gas and dust pile up and ignite new clusters, an elegant machine in orbit, roughly 170,000 light-years across, bigger than the Milky Way and laced with dust lanes that braid blue star-forming knots into each turn of the helix. Herschel first logged this whirl in 1790. 2 centuries later, it became a rung on our cosmic yardstick when Hubble tracked the heartbeat of its Cepheid variables, those candle-like supergiant stars whose rhythm-to-luminosity code let astronomers pin down the galaxy's distance and tighten the calibration of the Hubble constant. Even its address tells a story, listed with the Fornax cluster, yet nudged to the outskirts, and possibly a touch beyond the main core. This galactic coil drifts in a web of neighbors, its starlight crossing intergalactic space to reach our telescopes, bright enough that a modest 8-inch instrument under a southern sky can catch its soft oval glow. When you watch its spiral unfurl on screen, dust veils shading pink H2 beads, older amber stars pooling toward the nucleus, faint satellite fuzz and background galaxies sprinkled like iron filings, it feels less like a photograph and more like time captured in motion. A spring storing angular momentum and paying it out in starbirth, rotation, and the quiet pull of dark matter shaping a disk we can map but not touch. This is the kind of galaxy that turns a night into a question: how does a universe so vast produce geometry so precise, texture so delicate, and a rhythm steady enough that we can measure the cosmos by stars that blink like metronomes? Tonight, the galactic coil, the stellar mainspring, the celestial helix, the Fornax spiral, invites you to lean in and feel the tension of a clockwork that runs on gravity, gas, and light. Drop into the disk and you can feel the choreography. Stars stream like traffic on a multi-lane highway while a slower-moving pattern, spiral density waves, rides through them, gathering gas into ridges that wrinkle, shock, and flare into clusters. The stellar mainspring funnels momentum through these crests, and where orbit speeds match the pattern's rotation at corotation, material lingers just long enough to be swept into nurseries. In the ultraviolet those nurseries blaze with hot, short-lived giants. In hydrogen alpha they trace filaments and arcs that sketch the wavefronts with surgical precision. In the infrared you see the soot of yesterday's births cooling toward tomorrow's planets. Follow the lanes and notice how physics stacks in layers. Gravity herds molecular clouds, turbulence fractures them from giant complexes to star-forming cores, magnetic fields thread the fractures and guide flows, feedback from newborn O-stars, winds, ionization, and, a few million years later, supernovae, punch cavities that vent energy into the surrounding medium. The celestial helix becomes a living circuit, gas collapses, stars ignite, pressure rises, shells expand, fresh shocks seed the next round. On galactic scales the Kennicut, Schmidt law ties this ballet together: more surface gas, more starlight, yet the rule is punctuated by local surprises wherever shear, shock speed, and cloud lifetimes line up just right. Listen for the hum of rotation. Out beyond the bright lanes, orbital speeds refuse to fall the way Newton would predict from starlight alone. A dark halo carries the load, keeping the curve flat and the disk stable enough to persist for billions of years. That invisible scaffold sets the pitch angle of the arms and the pace at which the Fornax coil winds itself, while resonances, inner and outer, quietly sculpt rings and gaps that a trained eye can spot like fingerprints. Over time, stars wander, some migrate outward on near-circular paths, others heat up and thicken the disk, smearing metallicity gradients into a soft fade from enriched, bustling inner regions to cleaner, quieter outskirts. Each orbit writes chemistry into geography. Pan wider and the neighborhood starts whispering. A cluster tied here, a flyby there, and the spiral clockwork tightens, loosens, or sprouts a kink. Even a barless disk can host transient armlets or lopsided wakes if a passing dwarf nudges its outer gas. The gravity spring holds its form, but you can read past encounters in faint plumes and asymmetries that surface after long exposures, ghost script on a page that's still being written. This is not a static postcard, it's a machine running on angular momentum and cold hydrogen, tuning itself as it trades torque with the cosmos. Now imagine dropping a probe through the plane. Dust reddens starlight into amber, the microwave hiss of the background is a steady metronome, cosmic rays skitter along field lines, and in the radio you hear neutral hydrogen singing a 21-centimeter line that maps the disk like sonar. Every wavelength adds a voice to the chorus, and the starlit torsion reveals new structure each time you change the dial. By the time the camera tilts back to the nucleus, older, cooler stars pooling like molten gold, you can sense the clockwork behind the beauty, a regulated release of stored order into newborn light. Stay with that feeling as the galactic watchspring turns. The question isn't just how such a form arises, but how it keeps time so well that we can measure the universe against it, using standard candles that pulse with algebra we've learned to read, using rotation we can weigh, using spectra that turn color into composition. When the frame finally settles, the luminous coil you met at the start has become a laboratory, gravity translating geometry into stars, feedback carving voids into canvases, dark matter holding the stage while the actors dance. And that's why you can't look away, because the next arm crossing is already sharpening somewhere off-screen, and the next generation of suns is waiting in the wings of this radiant spiral engine. Tilt the camera toward Fornax and a luminous coil snaps into view, a spiral so clean it looks engineered. The cosmic spring unwinds as an unbarred S.A.R.S.B disk, moderately tight arms, a faint inner ringlet where orbits pile up, dust filaments braided with newborn clusters, and a calm, older core that glows like banked embers. Scale it in your head, roughly 170,000 light-years from rim to rim, larger than our Milky Way, and sitting about 71 million light-years out, far enough that every photon you're seeing began its trip when early humans were just inventing metallurgy on Earth. William Herschel first logged this whirl in 1790, 2 centuries later. Hubble watched its Cepheid variables pulse and turned those beats into a distance, a crucial rung in the ladder that lets us measure the universe. Slide inward and the machinery starts to speak. Spiral density waves drift through the stellar sea like weather systems, compressing gas into lanes that wrinkle, shock, and ignite into associations of hot, short-lived giants. The galactic mainspring doesn't just look wound. It stores angular momentum and releases it as ordered rotation, while resonance zones, inner, corotation, outer, act like traffic circles that gather dust and molecules into rings and pseudorings where star formation spikes. That tiny RS in its classification is a clue to this choreography, a partial ring where the pattern speed and orbital motion talk in phase, a place where structure lingers long enough to build. Listen in other wavelengths and the picture deepens. Neutral hydrogen at 21 centimeters maps a disk that stretches beyond the visible arms. Its global line profile is broad and symmetric, the telltale signature of a fast, well-ordered rotator whose outer speeds refuse to drop with radius. That flat curve is the classic dark matter signal, gravity from unseen mass propping up the spin so the disk doesn't unravel, a hidden scaffold keeping the stellar coil taut over billions of years. Star birth here is not a constant drizzle. It comes in measured gusts. Hubble's deep imaging of massive star populations hints at a fresh uptick roughly 10 million years ago, short on cosmic clocks but long enough for bright OB associations to carve bubbles, lace the lanes with H-alpha arcs, and leave soot in the mid-infrared that tomorrow's planets will inherit. Feedback from winds and supernovae punches chimneys through the disk, venting energy and seeding the next round of collapse along the arm crests. The celestial helix becomes a looped circuit, compress, light, pressurize, shell, cool, collapse, each turn of the pattern writing chemistry into geometry. Zoom back to the big picture and the neighborhood starts to matter. Catalogs tie this world to the Fornax family, but surveys of gas and galaxy motion suggest it may skate the outskirts or even a touch beyond the cluster proper, a reminder that clusters have long, ragged edges and that infall, flybys, and tides quietly sculpt spirals for eons. Environment sets the background tempo, the Fornax gyre plays its melody on top, tightening or loosening arm pitch, nudging lopsided ripples into the outskirts that only surface on deep exposures. For distance hunters, this disk is more than a pretty face. Its Cepheids were part of the Hubble Key project, the campaign that cross-checked cosmic yardsticks from variable stars to type Ia supernovae and Tully-Fisher spins, tightening our estimate of the Hubble constant. When you see a variable in this galaxy blink, period up, luminosity up, you're watching algebra in the sky, a relation that turns rhythm into reach, brightness into miles, and a single galaxy into a measuring tool for the expansion of space itself. Later, infrared photometry and rotation-based scalings kept the calibration work going, because better distances ripple through everything from dark energy fits to the age of the cosmos. Drift through the lanes in imagination and the physics stacks in layers. Gravity corrals giant molecular clouds, turbulence shreds them into cores, magnetic fields thread the shreds and steer flows, ultraviolet from newborn stars ionizes skins that glow in hydrogen lines. A few million years later, supernova shockfronts sweep up the remains and trigger the next generation along the ridge. Across the disk, the Kennicutt-Schmidt rule, more surface gas, more starlight, holds on average, but local exceptions pop wherever shear, collision speed, and cloud lifetimes line up just right. Stellar migration then smears the metallicity gradient. Some stars surf resonances outward without getting much hotter, others scatter and thicken the disk, turning a sharp chemical slope into a soft fade with radius. The astral torsion you admire on screen is the visible trace of these invisible negotiations. Even the color tells time. Blue knots mark recent births, amber pools near the nucleus reveal older populations, with carbon-rich giants and red clump stars padding the light. Dust veils carve shark fin silhouettes against the bulge. In the mid-IR, PAH features whisper of photochemistry. In the far IR, cold grains count up the raw material left to spend. Put radio, optical, ultraviolet, and infrared together and the luminous spiral engine becomes a four-dimensional object, a cross-section of motion, composition, and memory. And then there's the simple, stubborn fact of rotation. Measure the tilt, take the widths of the hydrogen and CO lines, correct for inclination, and a number falls out that places the stellar mainspring on the Tully-Fisher ridge alongside other fast, bright disks. That one point helps anchor a relation used from the local volume to surveys that reach half the age of the universe, a line on a plot that turns spin into wattage and wattage into distance. It's prosaic, almost bureaucratic science, until you realize that the elegance of this single galaxy helps set the scale of everything. So when the frame glides over the nucleus and the arms sweep past like the teeth of a gear, don't just see a postcard. See a regulated release of stored order into light, a conversation between gravity and gas moderated by dark matter and time. See standard candles ticking in the background like metronomes, see radio profiles tracing the reach of the disk, see resonance rings quietly accumulating the raw ingredients for tomorrow's suns. The galactic coil, the stellar spring, the celestial helix, the Fornax spiral, choose the name you like. Each is a handle on the same precision instrument, a clockwork of stars whose ticking lets us read the age, size, and speed of the cosmos, and whose beauty makes you want to press play again. Tilt a little farther and the disk stops being a postcard and turns into a laboratory. Across each arm there's a time gradient you can actually read. Upstream, gas is compressed and dust lanes run dark and narrow. Just downstream, ultraviolet stings the eye where newborn O-stars switch on. Farther yet, the blue fades to white as those giants die and leave behind clusters of mid-mass suns. That staggered color band, shock, ignition, aging, is the signature of a traveling wave, not a rigid piece of the galaxy. The stellar corkscrew moves as a pattern, shepherding material that orbits faster on the inside and slower on the outside, like traffic flowing through a city whose lights are green on a slow, majestic schedule. Zoom to the inner few kiloparsecs and watch orbits talk to the pattern. Where the epicyclic rhythm of stars and gas matches the wave at an inner resonance, material piles up and sketches a partial ring. That's the quiet hint hidden in its classification, a pseudo-ring born from dialogue between gravity and motion. In these crossroads, cloud lifetimes lengthen just enough for collapse to finish, so nurseries bloom in strings, pearl-on-a-wire associations that outline the crest the way foam marks a breaker. If you could pause time and dissect one of those birthplaces, you'd find a whole cascade of processes layered together: turbulence fracturing a giant cloud into dense knots, magnetic fields channeling flows into filaments, radiation from the first ignitions carving cavities, supernovae a few million years later driving shells that seed the next round along the arm. Step into radio light and you can weigh the whirl. Neutral hydrogen sings at 21 centimeters from far beyond the bright optical rim, and its line widths refuse to narrow with radius. That flat rotation is the fingerprint of a dark halo, a massive, invisible envelope keeping the spiral taut. Without that extra gravity, outer orbits would slacken, arms would shear apart, and the starlight coil would unravel. Instead, the rotation curve holds, swing amplification keeps patterns alive, and the disk remains a long-lived stage where starbirth can keep rehearsing new acts. In the infrared, the dust glows with the warmth of starlight it has swallowed. Polycyclic features sketch luminous knots where radiation is strong, colder grains map reservoirs of raw material still waiting its turn. Switch to H-alpha and you see the cut edges of ionized bubbles. Go to the far ultraviolet and the hottest, shortest-lived giants burn white scars across the lanes. Every band is a different accent in the same sentence, and when you layer them, the Fornax gyre stops being flat. It becomes four-dimensional: place, motion, chemistry, age. Even randomness has a role. Not every arm segment obeys the average rules. Where shear weakens or two cloud streams meet, star formation spikes above the mean, and where feedback has just vented a superbubble, it can dip. The classic surface density law still frames the story: more gas, more stars, but local weather writes the plot twists. Over hundreds of millions of years, stars migrate. Some surf resonances outward while keeping nearly circular paths, softening metallicity gradients. Others scatter and thicken the disk, raising the scale height so the galaxy wears a faint, older atmosphere above its bright plane. Tilt the view and you catch that ghostly envelope, a fossil of dynamical heating events long past. Listen for quieter actors. Planetary nebulae blink in the outskirts, tiny emerald rings around dying suns that help trace motions where starlight is thin. Globular clusters hang farther out like bright buoys, recording the earliest assembly history. In between, a web of faint streams and asymmetries can betray long-ago encounters: a dwarf brushing the rim, a tidal tug from a neighbor, that left ripples you can only see when the exposure runs deep. The spiral clock spring looks serene, but it remembers. Now imagine dropping an integral field spectrograph across the face and turning each pixel into a spectrum. Lines split and shift with rotation, widths fatten where turbulence grows, oxygen and nitrogen ratios map the chemical past, and age indicators peel back the birth order of stars across each arm. You could even estimate the pattern speed by reading the color offsets between dust, H-alpha, and blue light, timing the choreography from shock to ignition to fading. On a different night, the Tremaine-Weinberg method would let the old stellar population itself reveal the patterns turned by the way its light and velocity field line up, a galactic metronome you can measure. What about the center? There's no need for fireworks to keep the story compelling. A calm, evolved bulge anchors the disk like the weight of a flywheel, its older populations pooling in warm tones that contrast with the icy blue of the arms. If a modest black hole hides there, it works as a librarian more than a showman, quietly curating orbits, shaping dispersion, holding the city's downtown together while the suburbs keep expanding with new construction along the lanes. Pull back to human scale and the numbers start to feel like poetry. Light left this celestial helix tens of millions of years ago. In the meantime, clusters have been born and died, supernovae have salted the lanes with heavy elements, and shock fronts have marched a few hundred parsecs downwind. Yet when those photons land, they still carry a clean blueprint of order threaded through chaos, geometry drawn by gravity, texture carved by feedback, continuity guaranteed by a dark frame we cannot see but can weigh. That's why the image doesn't just look beautiful, it reads like a proof. If you're watching on a screen, consider what it took to make this view: mirrors polished to fractions of a wavelength, detectors counting single quanta, software peeling sky glow from signal, and observers patient enough to tug secrets from noise. All of it so we can stand here, for a moment, inside a whirl of cities of suns and feel how steady the universe can be when you average over storms. The astral galoche, the luminous coil spring, the stellar torsion, the galactic corkscrew, pick any name and it will fit, because each is only a handle on the same astonishing engine, a regulated, rotating foundry that turns cold gas into starlight and keeps time well enough for us to set our cosmic clocks by its beat. Shift your gaze to the outskirts of the whirl and you'll notice the rules of balance written in starlight. The outer lanes look delicate, but stability lives in the numbers. Gravity tries to collapse the gas, shear tries to pull it apart, pressure and magnetic tension negotiate a truce, and the disk chooses a thickness that keeps turbulence alive without tearing structure to ribbons. Where the tumor parameter drifts near unity, clouds can tip from trembling to condensing. Where it rises, the pattern thins, armlets fade, and starbirth pauses until compression returns. The spiral clockwork doesn't need violence to evolve, it leans on thresholds, tipping points, and the steady bookkeeping of angular momentum. Inside those pearled lanes, dust grains run their own microphysics. Silicate shards and carbon soot coat themselves in ice in the cool shadows, then shed mantles when ultraviolet returns, changing how they absorb and scatter light. Photoelectric heating flicks electrons off tiny grains and warms the gas just enough to keep it buoyant, while larger particles drift and settle toward the midplane, a quiet preface to the disks that one day learn to build planets. Even without a telescope, you've seen the sign of this chemistry, the warm infrared glow that outlines the ridge trails like embers under ash, a census of raw material recorded in wavelengths longer than your eyes can see. The luminous coil spring teaches orbital subtlety too. Stars don't just spin in circles, they bob above and below the midplane, trace epicycles around their mean paths, and trade a little radial energy for a little azimuthal drift whenever they meet a resonance. Over hundreds of millions of years, that slow traffic redistributes metals, fresh elements forged in supernova ovens bleed outward, diluting the inner richness into a gentler gradient that observers can read off oxygen lines like rings in a tree. The light-wound disk remembers every push, minor tides from neighbors, the whisper of the cluster's potential, even the self-gravity of its own arms, and folds those nudges into today's geometry. Watch the interstellar medium change phase as the camera slides along a lane. Atomic gas cools into molecules inside shielded pockets, CO traces the densest knots, ionized skins glow where massive stars wake, hot bubbles fill with X-ray plasma where winds and supernovae overlap. None of these states is permanent. The gravity wound carousel cycles through them like a weather system, each phase seeding the next, collapse, ignition, feedback, dispersal, and renewed collapse when the shock front meets fresh supply downstream. That's why the arm crest looks braided rather than smooth, multiple episodes braided into a single luminous rope. If you could park an integral field spectrograph across the face, you'd hear rotation turn into music. Velocities split emission lines cleanly on one side, blend on the far side, then meet at systemic in the middle, a Doppler sonogram of the entire disk. Absorption features from older stars add a softer harmony, revealing a velocity dispersion that rises toward the nucleus, a sign that orbits there are more mixed and the stellar population more mature. Map line ratios and a chemical atlas emerges, lower ionization in the outskirts, higher metallicity toward the center, little islands of harder radiation near young clusters where shocks or winds sharpen the spectrum. Even quiet centers write strong stories. A moderate bulge anchors the field like a flywheel, preventing bar instabilities from running away and letting the pattern live long enough to grow its fine filigree. If a black hole sits in that hub, and galaxies of this mass often do, it can be modest and still matter, gently shaping stellar orbits and acting as a ledger for the deepest potential well without resorting to drama. The star wound spiral doesn't need fireworks to be unforgettable, its elegance is the point. Step back once more and think about what this single system buys us scientifically. A clean, unbarred disk with a faint inner ring is a near-ideal testbed for density wave theory, for swing amplification in shearing sheets, for how feedback regulates star formation efficiency to a few % per freefall time instead of burning the pantry at once. Its flat rotation reminds us that luminous matter is only the frosting, a dark halo carries the cake, setting the tempo and keeping the arms from unspooling. Its multi-wavelength face, ultraviolet for newborns, H-alpha for ionized rims, infrared for dust, radio for the long hydrogen reach, lets us cross-check ages, masses, and motions until the narrative locks. And then there's the feeling you can't put on a graph. The coil of suns turns with a patience measured in hundreds of millions of years, yet every bright knot inside it lives fast and dies young, seeding the next act with metals, shockwaves, and light. The geometry is strict, the texture is improvisation. The result is a living proof that order can emerge from a sea of collisions and cooling and chance, that a galaxy can be both a machine and a garden. Call it the Fornax corkscrew, the orbital mainspring, the stellar spiral loom, the gravity spool of lights, whichever name you choose, the invitation is the same: lean closer, slow your breathing, and let a rotating city of stars show you how the universe keeps time. Swing the camera along an arm and the geometry resolves into engineering. Spurs flick off the main lane like braided off-ramps, feathered filaments where shear stretches clouds into pearls, then gravity pinches those pearls into clusters. At each kink you can read the downstream timeline: dust first, then ionized rims, then a trail of aging blue stars drifting into the interarm sea. Giant molecular complexes stitch themselves into beads on a string at nearly even spacing because gravity, rotation, and sound speed conspire to pick a preferred wavelength. Change the gas fraction and you change the stitch length, tweak the shear and you tilt the feathers. What looks like ornament is actually the disk solving fluid equations in real time. Out beyond the bright lanes, the low surface brightness outskirts take over, and subtle warps begin to whisper. The stellar sheet flares, the gas layer puffs up, and corrugations, gentle vertical waves, ripple through the outer plane where tides and past flybys have nudged orbits. Star formation thins to a lace of H2 islands that live right at the stability threshold. Ultraviolet shows a ghostly ring of newborns where the gas just barely tips from safe to unstable. In these suburbs, metallicity drops, dust grains grow cleaner ice mantles, and the interstellar medium flips phase more slowly. The coil looks delicate here, but the dark halo's grip is firm, keeping orbits fast enough to hold the pattern together even where starlight fades. If you could float inside the interarm regions, you'd discover they're not empty at all, just quieter. Diffuse molecular gas hides under the detection limits that catch only the brightest knots, cosmic rays leak from old superbubbles and keep the medium warm, and magnetic fields provide springiness that lets clouds rebound instead of collapsing wholesale. Efficiency is the watchword. Only a few % of mass turns into stars per freefall time, regulated by turbulence, feedback, and the slow rain of fresh material drifting in from the outskirts. That restraint is why a disk can shine for billions of years without burning itself out. Glide back toward the hub and listen to dynamics turn into arithmetic. Pattern speed sets the separations between resonances. Those resonances set where rings and gaps gather. The rings and gaps decide where gas lingers long enough to collapse. The old stars in the bulge carry higher random speeds, thickening the center into a warm, rounded glow that acts like a flywheel against runaway instabilities. Even a modest central black hole, if present, need not shout. Its gravity adds a quiet depth to the well, tightening orbits and helping the nucleus keep its shape while the arms keep time. The whole device is a feedback loop written in orbits. Gravity focuses, feedback relieves pressure, rotation redistributes, dark matter holds the frame. Now step outside the galaxy altogether and think like a survey. A clean, unbarred whirl with a faint inner ring is a gift to observers. You can apply the Tremaine-Weinberg method to the old stellar light to clock the pattern, then compare that to the offset between dust, H-alpha, and blue starlight to time cloud life cycles. You can place the system on the Tully-Fisher relation with a single high-quality HI profile and watch it land right where a fast, luminous disk should. You can map oxygen lines from center to rim and watch the gradient soften where radial migration has ferried metals outward. Each measurement is a verse in the same poem, and taken together they show how a rotating sheet of gas, helped by an invisible halo, writes structure into the night. Keep the frame rolling and the names keep coming because the object keeps deserving them. The Fornax corkscrew when you want to feel motion, the luminous watchspring when you want to hear the tick of resonances, the stellar loom when you want to see threads braided into arms, the gravity spool when you want to picture torque winding light into shape. Whatever you call it, the message is the same: order is not an accident here. It is earned, maintained, and renewed, cycle after cycle, as this radiant gyre turns cold hydrogen into cities of suns and lets us, tiny and recent, set our clocks by its unhurried beat. Slide back into the disk and watch the lanes breathe. The stellar coil turns, and along each ridge tiny shock fronts flicker like distant weather, sweeping gas into knots that light up and fade as they drift downstream. The pattern isn't a sculpture, it's a signal passing through matter, leaving behind chains of clusters the way a tide leaves arcs of shells. Between the arms the scene is hushed rather than empty, thin filaments, stray associations, a low hum of radiation keeping the gas from sleeping too deeply. The camera glides and the celestial helix keeps its tempo, a steady rotation underneath quick bursts of creation. Closer to the nucleus the light shifts from ice blue to warm gold, a quiet district where stars have aged into balance. The core doesn't roar, it steadies. Around it, a subtle ringlet marks where orbits linger just long enough for clouds to coalesce, a roundabout for interstellar traffic. Dust veils crease the glow, thin as smoke and stubborn as thread, sketching the flow of material by the way they dim and redden the starlight. Tilt the view and the lane relief pops, edges sharp on the windward side, feathered on the lee, a textbook of motion etched into glow. Follow a single cloud through one arm crossing. First, pressure rises and the clump tightens. Then newborn giants switch on, and their light carves cavities whose rims burn in hydrogen. Winds pile shells, shells run into neighbors, neighbors shock and cool into the next generation. By the time the cloud reaches the far edge of the lane, it's a loose association of medium-mass suns, the heavyweights already gone, their metals salted into the dust for future worlds to borrow. The spiral loom has advanced one stitch, the fabric is thicker by a whisper. Out near the faint rim, structure thins and the rules soften. Warps nudge the plane by a few gentle degrees, the gas layer lifts, and star-forming islands dot the outskirts like campfires far from town. Here the Fornax corkscrew looks fragile, but the spin holds, outer stars circle with a confidence that belies the low light. Background galaxies prick the field and remind you the stage is larger than the set. Even here, a few blue pricks flash and fade, proof that the engine still catches at the edge of its reach. Drop into radio hearing and the galaxy becomes a map of motion. The far side's lines slide redward, the near sides slide blue, and the middle rests at the system's heartbeat. Switch to infrared and the dust answers with a soft glow that outlines reservoirs you cannot see in visible light. Turn the dial to ultraviolet and the newborns dominate, stark and temporary. The luminous watchspring refuses to be one thing, it is a stack of truths, each band telling a different part of how gas becomes light. There's memory in the geometry. Old stars wander from where they were born, blurring sharp gradients into gentle slopes, faint streams in the outskirts hint at visitors long gone. Even the thickness of the disk records a history of nudges, a vertical hush over the bright plane that only shows when you change the angle. You can read patience in that hush. The galaxy is not in a hurry, yet it never stops. Think of the numbers as choreography rather than math. A single pattern speed sets where lanes form, those lanes set where clouds stall, those stalls set where clusters ignite. Feedback prunes what would otherwise run away, so the pantry isn't emptied in one bright blaze. The result is longevity with texture, a machine that moderates itself, a garden that reseeds as it harvests, a city that repaves the road as it drives. Now widen the frame and let the context in. The gravity spool drifts among neighbors like a skater on a crowded pond, feeling their pull but keeping its line. Tides reshape the faintest edges, not the core. Encounters leave rumors more than scars, a lopsided rippling here, a twist in the gas layer there, clues a deep exposure will reveal like handwriting bleeding through a page. The main story remains intact: rotation, compression, ignition, drift, repeated until the disk has told it in every quadrant. When the shot finally coasts past the nucleus and slides along the far arm, notice how your eye already knows the sequence: dust, rim, blue, quiet. That familiarity is the hook. It means the stellar torsion is not chaos but cadence, a rhythm you can learn by watching, and a promise that the next crossing will play the same song with new notes. You're not just looking at a picture, you're watching a process that makes suns, worlds, and the chemistry that can one day look back. Call it the galactic corkscrew, the astral mainspring, the spiral loom. Names are handles, not cages. What matters is the feeling when the camera lingers and the pattern keeps turning: calm under complexity, order without rigidity, a universe that writes elegance into a rotating sheet of stars and invites you to read it aloud. Drift along the outer disk and watch the spiral turn from luminous architecture into lived weather. Between the main lanes, faint feathers peel away and curl like wind-blown streamers, their spacing set by the tug-of-war among gravity, shear, and sound. Each feather seeds a string of clusters with almost musical regularity, pearls spaced by a preferred scale that the fluid equations quietly choose. The interarm sea is not idle, it's a slow workshop where leftover gas cools, tangled fields relax, and tomorrow's clouds assemble from whisper-thin filaments that your eye barely catches until a newborn association lights them from within. Slide inward and the traffic pattern tightens. Orbits crowd a subtle roundabout near the center, and cloud caravans linger long enough to finish the last steps before ignition. You can read the age gradient across every lane without a clock: soot-dark ridges at the shock front, thin ionized skins glowing like hot metal where massive stars switch on, then a downstream trail of mid-mass suns drifting into the paler spaces between arms. Feedback edits the draft as it goes: winds hollow bubbles, supernovae lace shells into the next crest, and ultraviolet bleaches dust into translucent veils that outline where the pressure waves just passed. Turn the galaxy on its side in your mind and the vertical story appears. Stars bob above and below the midplane on gentle springs, thicker toward the center where random motions are stronger, thinner in the outskirts where the sheet stays cool. Corrugations ripple through the far rim, soft bending waves likely started by ancient nudges, and the gas layer flares until the spiral looks like a lantern with a faint halo, old light hovering above the bright streets. Even that hush is a ledger, every ripple, every extra thickness, a memory of tides and passages folded into today's equilibrium. Follow the chemistry as it cycles. Atomic hydrogen chills inside shielded niches until molecules form, dense knots gather carbon monoxide and trace the routes of impending collapse. Radiation from newborn giants peels back the skins and leaves arcs that shine in hydrogen lines. Dust grains carry the history from scene to scene, icing over in shadows, shedding mantles in glare, becoming catalysts and thermometers at once. In the infrared, they reveal reservoirs your eyes can't see; in the ultraviolet, they betray where the fire was hottest last. Listen to rotation like a low drum that never misses a beat. Speeds hold steady far past the bright lanes, keeping the outer scaffolding taut so the pattern can live for eons. That steadiness is why the star-threaded gyre can mix without smearing, migrate without losing its face, and teach the same lesson in every quadrant. Order persists not because nothing happens, but because many small storms cancel into a larger calm. Now imagine a night beneath this sky from a quiet world inside one of those lanes. The Milky Way you know is replaced by a band mottled with dark scallops and bright knots, nebular rims arcing like embers along a vast curve. Over a human lifetime the stars won't shift, yet a telescope would catch bubbles expanding, clusters aging, supernova remnants cooling into faint filigree. The city of suns looks frozen only because your clock is small. On the galaxy's clock, districts grow and retire while the whole town keeps its circular commute. Pan to the outskirts again and watch the rules grow permissive. Metallicity's thin, dust runs cleaner, and star formation proceeds in sparse outposts perched right at stability's edge. A passing dwarf might write a single italic curve into the gas, then disappear into the dark, leaving only a twist you notice in very deep frames. The Fornax scroll wears its history like a watermark, subtle, distributed, easy to miss until you know where to look. Return to the heart and the color warms. Old giants pad the light in gold, kinematics stiffen, and the bulge acts like a flywheel that steadies the stellar gyroscope. There's no need for a roaring nucleus, a modest, well-behaved center holds the plan together while the suburbs get on with building. The contrast is the point, quiet authority at the hub, improvisation along the lanes, patience at the rim. Think in rotations instead of years. One full turn of the disk takes a few 100 million Earth years, long enough for clouds to cycle from sea to ash and back again, short enough that the pattern still remembers its last song when the next chorus begins. Migration ferries metals outward, smoothing steep gradients into gentle fades, newborns spice the spectrum with short, hot notes, elders round the chords into something mellow. The light wound engine is both composer and orchestra, writing structure with gravity and performing it with gas. Hold the final wide shot and let the symmetry breathe. Two principal arms carry the melody, secondary feathers riff along, the inner roundabout anchors the rhythm, and the unlit frame keeps time so everything lands where it should. Call it the astral coil, the orbital scroll, the radiant whirl, the starlight gyre, names are lenses. What endures is the feeling, a rotating city that turns cold hydrogen into suns with unhurried confidence, a gravity clock that measures patience in light, a living proof that the universe prefers cadence to chaos. Keep the shot rolling and let the spiral's quiet arithmetic turn into lived moments. A newborn cluster cracks open the dark like a struck match, its hottest stars scouring a bubble whose rim glows and then thins as gas leaks into the interarm sea. A few arm lengths away, an older association drifts in pale blue, its brightest members already gone, a dusting of heavier elements folded back into the lanes for whatever comes next. The astral coil doesn't waste anything, it circulates, cloud to star, star to wind, wind to shell, shell to cloud, until the map itself becomes a memory of all the cycles it has survived. Tilt the angle and the streets of starlight sharpen into neighborhoods. You can pick out chains of clusters like beadwork along the crest, each spaced by the same quiet compromise between gravity and sound. Between those strings, faint veils hang where ultraviolet has bleached dust into translucence, the way morning burns mist off a river. The interarm spaces carry the murmur of diffuse gas and cosmic rays, a soft background that keeps the medium warm enough to resist collapse until the next pressure wave arrives. The luminous corkscrew holds its decorum while 1,000 invisible negotiations play out in every parsec. Closer to the hub, orbits braid so tightly that time itself feels denser. A mild roundabout gathers traffic, and the pace of change slows from flares to glows, older giants padding the light in bronze, velocity fields smoothing into a steady hum. If you watch long enough in imagination, you can see the city repave its avenues, resonances draw dust inward, feedback clears routes outward, and the stellar mainspring transfers momentum the way a watch shares energy between gears. Nothing shouts, everything contributes. Out at the edge, the rules loosen and the voice turns whispery. The sheet flares, the gas layer lifts, and the arm becomes a lace of small fires where stability hovers on a knife's edge. Here a ripple may be the whole story, a subtle warp changing the way light grazes dust, a twist hinting at an encounter so long ago that only the outermost gas remembers. The orbital helix looks delicate under shallow exposure, but a deeper stare reveals a scaffolding of motion that refuses to fray. Change wavelength and the personality shifts without losing identity. In ultraviolet the newborns are all urgency, in hydrogen light the rims trace letters you learn to read, in the mid-infrared the soot confesses where starlight was strongest, in radio the outer map extends beyond sight, a contour of motion that holds the entire composition together. The gravity scroll is not a picture so much as a chord, stacked notes, each essential, each incomplete alone. Think in orbits instead of seconds and patience becomes visible. While the disk completes a single turn, clouds are born and undone, elements are minted and shared, and the metallic paint on the inner districts is carried outward grain by grain. Some stars surf the pattern and keep their paths nearly circular, others bounce and thicken the sheet into a faint atmosphere above the bright plane. The starlight gyre edits itself with every revolution, keeping a recognizable face while quietly trading details with time. Imagine a planet under one of those lanes. Its night would carry a river of structured darkness and fire, dust seams scalloping a luminous band, nebular rims like embers nested inside grand curves. Generations would come and go without noticing the arm's march, yet a careful observatory would catch bubbles widening, filaments cooling, remnants fading. The radiant whirl is a teacher whose lessons are slow but constant. Pressure meets gravity, randomness meets rhythm, and the result is neither chaos nor stasis but a durable cadence. Pull back once more and listen for the piece that never changes, rotation, steady as a drum in another room. That beat keeps the outer scaffolding taut so feathers can grow without unspooling, lets rings accumulate without choking, and gives every burst a place to rest when the flare is over. Names are just doors into the same room, the celestial loom, the watchspring, the corkscrew, the light wound engine. Walk through any of them and you arrive at the same recognition, a rotating city that turns cold hydrogen into suns with unhurried confidence, a map of patience written in spirals, a living cadence that makes you want to lean closer and let it play one more chorus.